is most important phase of the adversary simulation, because we design our attack, how it should work, what tools to be used, and how we need to run this. In our TA505 Plus exercise, we will use a command and control suite. It's called Attack, and you can reach it out through my GitHub repository. It is open source, and you can customize your malware or command and control suite. It is developed using .NET Core to run on Windows, Linux, and Mac, and also .NET Framework to run on Windows 10 targets. You can get the source code using code and download zip, or you can clone and work on this repository. This is the file we can download as an archive. Today I will focus on how we can compile and run this implant on this test bed. Our test bed is a Windows system, so I will compile the server, which is the command and control service, and client, which is the implant, on the same system to make sure that we understand how we can compile this and how we can run this service. The customizations will be another video. Under the master folder, we will see two folders, Attack Service and Attack Implant. The service is quite easy to run and compile. It is simply the service itself, and if we have .NET Core installed on the system, we can just use .NET Run. .NET Run will compile this, and after compile, it will be able to run, and it will be running. As we can see here, it listens to port 443 and port 80, which are actually available under properties and launch settings. So you can change the port or other settings. Now it is listening to port 80 for HTTP connections and port 443 for HTTPS connections. We need to compile and test our implant now. Implant is in the same master folder, so we can just open this using Visual Studio. We can compile this manually, but Visual Studio will help you to automate some of the compile options. I'm just opening it, and Visual Studio is loading the solution and the project. It will warn about the repository because it is coming over internet. It is not safe exactly, so you need to trust the code to compile. And Patak is loaded right here. If you need to understand Patak and what are the basics, there are two videos here explaining that what is Patak malware, how it will work, and what are the features available for this type of simulations. Adversary simulation can be informed or uninformed, or just with collaboration. We call this with different colors, red team or purple team, but it is simple. It is an adversary simulation. So more details are in this video or the presentations. Now I'm going back to the source code. This is the source code of the malware. The configuration is important because we made our service running and listening to port 80 and 443. However, the implant doesn't know our IP address. We need to test this in our loopback interface first, and that's why I'm putting our loopback IP here and saving it. I will compile this, but before compile, I need to explain one thing here, which is important. Attack implant will need additional reference libraries and nuggets. You can manage them through manage nugget packages, or you can work on the references. One of the features here is important because it requires Newtonsoft.json. The reason behind of it is serializing the data coming as scenario. So the malware also runs scenarios and it needs JSON parsing. As a solution, I used Newtonsoft.json. Previously, it was SystemWeb JavaScript deserializer. However, this is not available everywhere, and this may have some consequences. It is similar for Newtonsoft as well. Newtonsoft is by default not available. To fix this issue, I actually changed this build sequence. That means when we build using Visual Studio will build this solution and will also add a new file which is compiled as a merged file. Patek implant is our malware right here, only 75 kilobytes. It's a .NET assembly. But Patek implant merged also includes newtons of JSON DLL as well. So this is your file to run standalone if you need to send this to the target system. Now we need to test this. Our service is running here and Patek merged is here. And when we run this, we receive these lines. That means we created a recent log here under the Patek service. I'm going back to the service folder and you will see the logs are here. And this is the log file. And we can see if there is any action here. This is the implant ID. When we use list, we can see all of the implant IDs connected. There is only one now, which is on the left. Now I'm just simply connecting it and running some sample commands to make sure that everything is aligned well. For example, exec net users. It simply lists our users here. We can also run some tests here as well, but that will be a second step or third step for us. The implant log will have all these commands as well as outputs. So we will have raw logs to work on. If we run some scenarios, that's also possible. The scenario features will be also available. This is the scenarios folder, and there's a sample scenario here. We can open the scenario using Notepad right here. And we can run this on this system. I'm only running these two instead of all and saving it. These are IDs for TTPs. These are the TTP JSON files. I'm opening now 87.1 and 2. This is the TTP file. So our implant will follow a scenario which is based on tradecraft techniques and procedures. That's why they are called TTP. It will simply run these instructions, and these are mapped MyTraTech IDs, and these are descriptions and names. So it will construct the scenario based on these TTPs. Whenever you add more TTPs, your scenario will be way more rich and useful. Now I'm just using a scenario now, going back, and the main menu, I'm using scenario command against the session we received, and this is the file path. We can use only scenarios here as well. Now, we have a scenario executed here, and our scenarios command shows that the demo trade actor scenario has been complete. So we can get this detailed information here using the scenario ID. First, the summary. Second, the output. If we go up after the output command, this is the command we used. It simply shows us what type of command or scenario did run, and this will be presented per technique. So simply TTP 1087 type 1 simply says that enumerate the users, and it uses simply CMD net users, and it lists users. It also lists the groups, but this is only available for domain controller, and this is not available here. The second one is also another example. This will list the users in the domain or the groups in domain admins. As the system is standalone, the data is not available here, but as we can see, the command did run. We can also use export file name. For example, we can use test report, and it will generate the content, this report as a file. So simply if we run patak service, we will have logs folder having all these in raw format. Okay, this one is our scenario file encoded in base64, for example. But if we need user-friendly information is test report I just exported right here. And the test is over. So we know that our implant as well as service works. What we need to do is first delivering this implant to the target. Second, using our public IP address or the test network attacker IP address. And the first setup is over. So implant and command and control server is ready.